Welcome everyone to the webinar. The name of this webinar is Exploring Accessible Campus Maps using SAS Graphics Accelerator. My name is Ed Summers. I'm Director of Accessibility here at SAS. And I have a few co-presenters today that I'd like to introduce. We'll go ahead and get started with Lisa in the Zoom control room.
Hello, everybody. My name is Lisa Morton. I am a project manager at SAS Institute and R&D division. Happy to be here. Diane?
Hi, everyone. I'm Diane Bronner. I am an orientation mobility specialist with about 25 years experience in the field. I also manage the Passive Technology website. Back to you, Ed.
All righty. Thanks, Lisa and Diane. This webinar will be recorded, and you'll get one more email about this webinar, which will include a link to the recording. You can find recordings for all the previous SAS accessibility webinars at the SAS Disability Support Center at support.sas.com/accessibility. We have a lot of people on the webinar today, so for that reason, everyone is muted right now. I want to encourage you and invite you to ask a question in the chat within the Zoom user interface. We'll pause for questions at least once throughout the webinar. This webinar offers a solution to a problem that is faced by every single student with visual impairment or blindness. And that problem is that it's very difficult and even practically impossible to build a good mental map of a college campus without physically exploring the campus. And I can tell you from personal experience as a former blind student and a blind professional that even when I can explore a campus, whether it be a college campus or a corporate campus, building an effective and accurate mental map by physically exploring it takes a lot of time. So as a result of this, students with visual impairments or blindness often struggle to navigate a college campus. This anxiety and stress compounds an already stressful situation. So the goal of this webinar is to empower certified orientation and mobility instructors and perhaps the disability support staff at colleges and universities to alleviate some of that stress. And you can do that by providing a non-visual digital map. Over the last few weeks, Diane has worked with a current high school senior who is a rising freshman in college. He will attend college in the fall. And she's prepared a case study of a digital map, a non-visual digital map working with this particular student. So Diane, do you want to show us your case study?
Sure. So let me get my PowerPoint up and running here. It'll take it just a second to switch over. There it goes. Okay, so as an O&M instructor working with a high school senior this year, I typically dedicate my time during the spring semester to provide orientation lessons on the college campus. However, with COVID-19 and the stay-at-home order, that put an abrupt stop to my face-to-face as an O&M instructor. Using accessible digital maps, remote O&M instruction time can be used to create a solid mental map of the student's college campus. Traditionally, print and tactile maps are used to build a big picture of the campus layout, including the location of and spatial relationships between the major streets, buildings, and points of interest. An accessible non-visual map can also be used to build the same foundational concepts. So let's take a look at Victor. Victor's a case study, and this is a student that I've been working with. Victor's a rising college freshman who will be attending Elon University for a week this summer in July and will be starting full-time in August. Like most students transitioning to college, Victor's very tech-savvy. He is an independent traveler on his high school campus and in his community, and he has solid cane skills. His foundation orientation skills include tactile maps, spatial skills, problem solving, the ability to build a mental map. He uses O&M self-familiarization techniques, such as learning the perimeter of an area first. And in the case of the campus, that would be the boundary roads around the campus. And he seamlessly integrates a variety of high-tech, low-tech, and no-tech O&M tools. Victor applies all of these O&M skills in order to be a fearless and independent traveler. Okay, so normally with Victor, he would have received O&M instructions on the Elon campus during his final high school semester. But due to the lockdown, Victor was only on one group tour on campus over a year ago. So 3 weeks ago, I created and shared a non-visual digital map of Elon and the link to this SAS tutorial. Victor learned to use and explore the map all on his own. And the following week, we had a Zoom lesson in which Victor used the non-visual map to build a mental map of campus. So here on the slide is a picture of Victor during his Zoom lesson. So you can see him working hard there. All right, so the next week, we traveled to campus. That was last week. We traveled to campus, applying the mental map to the physical campus. So Victor confidently led the way around the perimeter of the campus and then to the major areas on campus. My role as the O&M was simply to read some signage and to periodically stop Victor and have him confirm his mental map by pointing to the major buildings and areas and streets on campus from his current location. I did not teach Victor specific routes. By the end of the 90 minutes of walking on campus, Victor was figuring out shortcuts through the center of campus and around buildings in order to get to specific destinations. Without the mental map, it would have taken Victor numerous campus lessons to accomplish what he learned in one trip to Elon. So, Ed, I'm going to stop sharing my screen so that you can get yours up and running here. Okay. All right, and while he does that, I want to talk just for a second the difference between a non-visual map and a visual map. So words in Braille do not look the same as words in print. Yet both Braille and print enable people to read. Similarly, non-visual maps do not look the same as a typical printed map, yet both maps provide the same information. The goal of the campus map is to label the various campus buildings and roads and their spatial relationships. Students can explore the map to learn first what's on campus, and second, to build a mental map of the campus in order to travel to the various destinations. A non-visual map is not intended to look like a visual map. Okay, Ed, do you want to do your demo?
Yeah. Can you hear me?
Sure can.
Okay, and you should be able to hear my screen reader as well.
Slower.
And I'll slow it down.
Elon University detailed map.
A little more.
Slower. Heading level 1 Elon University detailed map.
Can you hear that?
Yes, I can.
Okay, very good. Thank you. Okay, this is the map that Victor used to build his mental map of the campus before he went on the tour with Diane. And you may notice here that, as Diane mentioned, it does not look like a typical map you would think. And that is because it's designed for a non-visual interaction. All right, and I can tell by the text on the screen.
Elon University detailed map graphic. Accelerate Elon University detailed map button. The map contains 47 points. Label is quote name quote. Footnote is quote map data provided by Google Maps quote.
Okay, so I can tell from the description that this map has 47 points. And that's useful because a map with 47 points is a lot different than a map with 470 in the way that I might interact with it. So this is a relatively simple map, and I'm going to go to the Accelerate button.
The map can accelerate Elon University detailed map button.
There we go. And I'll just press that button by pressing the space bar.
Space. Untitled dash Google Chrome. Graph view colon SAS graphics accelerator dash Google Chrome. Hint colon screen reader. Users should disable the virtual cursor. Turn off quick nav or use forms mode to explore the graph. Chrome dash.
Okay. So the accelerate button exists on that page that I was just on because I've installed SAS Graphics Accelerator, which is how we explore non-visual digital maps. So I've opened the map in SAS Graphics Accelerator, and you should be able to see a circle in the middle of the screen, which we call the lens. Okay. And the point at the very center of that circle is my virtual location within the map. Now, when I lost my vision, my O&M instructor taught me how to use a long cane. And if you're not familiar with those, you may know them. They're typically in the United States. They're white with a red tip at the bottom. And the basics of using a long cane is that I hold it in my hand and I'll reach out in front of me, and I can sweep the cane in an arc that's about, for me, about 4 feet from my feet, where my feet are on the ground. And as I sweep the cane clockwise or counterclockwise, I can detect objects in the environment, and I can feel and hear where those objects are in relation to me. So, for example, the direction and the distance of the object that I encounter. It may be in front of me or off to the right or really close to my left, let's say. Now, we've designed the non-visual digital map interaction to model exactly the long cane experience that we experience in the real world. And the way we do that is using a virtual cane. So I'm in this map, and right now my virtual cane, I think, is probably about a mile long. And I want to explore the map like most congenitally blind people that I've seen do it, which is kind of to zoom in and start exploring a few points. Now, I lost my vision later in life, so I typically do the reverse. I typically look at the entire map first to get the overview and the cluster of points. But I've noticed that the majority of users tend to do it the opposite way. So we'll just zoom in. I'll press the plus key.
Equals 1,500 yards, showing 46 of 47 objects. Equals 1,000 yards, showing 45 of 47 objects. Equals 500 yards, showing 32 of 47 objects. Equals 250 yards, showing 7 of 47 objects.
All right. So I might go back out
Dash
one.
500 yards, showing 32 of 47 objects.
Okay. And now my virtual cane is about 500 yards, and I can move it in the clockwise direction by pressing page down. And I'm going to just turn off my JAWS announcement here for you so you don't get distracted by that.
Okay, none.
Okay. And I'll press page down.
North O'Kelly Avenue and Phoenix Drive, intersection roundabout, 313 yards at 1 o'clock.
Okay, I've encountered an object on the map. It's at 1 o'clock. It's about 313 yards from my current virtual location. And you may have heard that it's a roundabout. And I'm going to hear that one more time by pressing spacebar just to get more information about it.
North O'Kelly Avenue and Phoenix Drive, intersection roundabout, 313 yards at 1 o'clock.
Okay, so you heard a tone. And that tone was relatively low, a little lower than mid on the piano scale. And what that means, that gives me information, both spatial information and distance information, direct and distance, because you can't hear it over Zoom because Zoom doesn't support spatial audio, but the sound is being played using spatial audio, and I can tell that it's roughly in the center. And the tone that you heard is a little less than mid. That means it's a little less than mid point down my virtual cane away from me. So the objects that are close to me have a high pitch, and the objects out near the edge of the lens at the edge of my virtual cane have a low pitch. So let's keep going so you can hear a little bit different tone.
Chandler Fountain, acoustic landmark, 278 yards at 1 o'clock.
So that's at 278 yards, roughly in the same bearing, give or take. And I can tell that it's closer to 1 because I heard the tone is a little higher in pitch. And then I get the confirmation of the text that tells me that it's 278 yards. Now, thus far, we've encountered 2 points. And what's great about these 2 points is I get just a ton of information that I can use as a blind traveler from the information. So, for example, The previous point was a roundabout. Well, I know that roundabouts have a unique kind of auditory signature because I can hear cars kind of go around in a circle. It's much different than a stop sign or a stoplight. And then of course Diane created this map and she added this fountain, which is a great acoustic landmark for me. And I've noticed in exploring this map previously, there's a couple of water fountains on this campus which serve as great landmarks. So let's keep going.
LaRose Digital Theater Academic Building 339 yards at 2 o'clock. Ernest A. Cower ESR Business Center 313 yards at 2 o'clock. Colonnades Dining Hall 248 yards at 2 o'clock. Stolly Hall on Phoenix Drive Academic Building 462 yards at 2 o'clock.
Wow, so that was a really low tone, and it's way out there, 462 yards away, almost at the end of my cane. My cane is 500 yards right now, 500 yards long. And I can tell that this point is on the same road that was indicated at the roundabout. So let's play that one again.
Stolly Hall on Phoenix Drive Academic Building 462 yards at 2 o'clock.
It's on Phoenix Drive, but let me back up. I'll press the page up key to go counterclockwise now.
Chandler found North O'Kelly Avenue and Phoenix Drive intersection roundabout 313 yards at 1 o'clock.
Okay, so that's North O'Kelly and Phoenix. So I can tell then that Phoenix probably runs east-west or pretty close. So let me jump to this roundabout. That gives me a good anchor, because I'll know when I jump to the roundabout, I'll move my virtual location to the roundabout. And from that, I'll know exactly where I am. And when I get to campus physically, when I can physically walk to campus, I'll be able to kind of map what I learn here to that specific location when I stand at that location on Earth. So I'll just press enter.
Moving to North O'Kelly Avenue and Phoenix Drive intersection roundabout showing 17 of 47 objects.
So now I'm seeing 17 objects in my current lens, with my virtual cane being 500 yards long. So I'll just press page down now to explore clockwise.
Stolly Hall on Phoenix Drive Academic Building 247 yards at 3 o'clock.
So now Stolly Hall is due east. I can hear it totally 100% in my right ear. It sounds like it's a little closer, because in my previously it was 462 yards away. Let me press this again.
Stolly Hall on Phoenix Drive Academic Building 247 yards at 3 o'clock.
Yeah, so it's about halfway, 247 yards, halfway down my cane. And I can hear it right in my right ear, directly coming out of in my right ear. Now I'm going to jump to that location.
Moving to Stolly Hall on Phoenix Drive Academic Building showing 9 of 47 objects.
So now we're down to 9 objects. So that tells me, hey, we might be getting off maybe to the northeast corner of campus perhaps, because the number of points are starting to dwindle and it might be a little bit less dense out there. But now I want to sweep in a counterclockwise direction.
North O'Kelly Avenue and Phoenix Drive intersection roundabout 247 yards at 9 o'clock.
Okay, and sure enough, so this one now is due west. It's coming completely in my left ear. You can't hear it because the Zoom doesn't include the spatial audio, but I can tell that it's totally at 9 o'clock. All right, so the relationship of these two points, the roundabout and Stolly Hall, I've totally built a great mental map of what that is. So I can continue exploring, just kind of leapfrogging from point to point, exploring the campus, which is a good strategy for those folks who want to start kind of in the from the details and then build a bigger picture from those details. But before we stop the demo and take questions, I want to do one more thing. I want to find the hall, the hall that I believe might be a residence hall. Let's see.
Jump modal dialog.
I pressed J to jump to a point, and I'm going to type in
Virginia Residence Hall.
Yeah, Virginia Residence Hall. Okay.
Jump to location : list box. Virginia Residence Hall 1 of 1.
Okay, so those. I just typed in a few characters, and the 47 points on the map were sorted down to this one that matched that string. Virginia Residence Hall. Let's just assume that when I go to campus, when I start in the fall, I might be living in Virginia Residence Hall. So of course I'd like to know where that is and what's around it. So I'll just press return here.
Moving to Virginia Residence Hall, showing 24 of 47 objects.
Wow, okay. So I can tell there that within 500 yards of Virginia Residence Hall, there's 24 objects. So this Virginia Residence Hall might be right in the center of campus. which is really great because I'll be right in the thick of things. And then from here, of course, I might zoom in
250 yards, showing 12 of 47 objects.
just to get a little less, a little fewer points on the screen, so it makes it easier for me to explore them. And then I can use my virtual cane to explore from this current virtual location of Virginia Residence Hall. I'll press page down.
You are at Virginia Residence Hall. Young Commons on East Haggard Avenue, 198 yards at 1 o'clock. Smith Residence Hall, 223 yards at 3 o'clock.
Okay, and we can just continue more of the same as we did. So let's stop here for some questions. We've covered a lot of content. Feel free to type your questions into the chat box there, and Lisa can moderate for us, and Diane, and feel free to jump in as well.
Absolutely. And the questions are popping, Ed. We've been answering a few as we go. For example, somebody wanted to know if it was available on mobile smartphones, and we answered currently the app is not available on mobile devices. But let's dive into some of these other really good questions too.
Can we just elaborate on that one just a little bit?
Sure,
Yeah,
absolutely. Yeah.
Yeah. Diane, can you perhaps explain how Victor used his GPS app on his mobile phone to complement the information he got from the virtual map?
Okay, so first of all, the virtual map was done on his computer during the Zoom lesson, and it was to build that mental map. When we got to campus and, I parked and he wanted to confirm which way he was going or which way he was facing on campus, he pulled out his iPhone, he fired up Blind Square, did a quick look on there. He could also use his compass app, but he did a quick look to see which direction he was facing, if he was facing north or south. He found one point, which for him was the Colonnades neighborhood, because that's the neighborhood he's going to be living in this summer. He put that in there. He got the bearing, the time and the distance in which direction it was, turned off his iPhone, and then did the rest from his mental map. So he just needed that starting point information to confirm where he was on the physical map, and then went from there.
Great.
Right. So the main thing, I guess, is that the power behind this is that you can build a mental map. Victor did not need to be taught rote routes. I did not tell him step-by-step directions on how to get to Colonnades neighborhood. He figured out it was at 11 o'clock. He went in the 11 o'clock direction. If there was an intersecting sidewalk, he figured out which way to go in that, because he was maintaining that distance of traveling 11 o'clock and then using the yardage to help him figure out how far away it is.
Perfect. All right. Next question, Lisa.
Great, sure. Would it be possible to generate a list of elements on the map?
Sure. Yeah, just to be able to see them as a list. Yeah, the way that I would do that is, let me see if I'm still here.
Jump modal dialog. Search.
Yeah, I'd press J when I'm exploring the map, and that gives me a list of elements on the map, objects on the map, which I believe is in alphabetical order, if I'm not mistaken. Let's see, let me tab to it.
Jump to location : list box. Virginia Residence, Whitley Auditorium, William Henry, Whitley, Virginia, United States, Stolly Hall, South.
Yes, it appears to be in alphabetical order, and from there I can just explore it and hit escape, or I can jump to one of those if I want to. There we go. Next question.
Sure. And I think you and Diane did a great job covering this one from Justin. But Justin wants to know, so does someone have to create this map prior to a blind person using it?
Yeah, Diane, do you want to take that one?
Sure. This is the map that I created for Victor specifically. So I can create, I customize the map. So I can do all the points on campus. I can decide to do just a few points on campus. It's up to me. But yes, I did create this map for him.
And Diane, when you create maps, do they all kind of look the same, or do you vary the map based on the student or the situation? How do you go about that?
Oh, absolutely. I knew Victor is very tech savvy, so I gave him the entire map to run with. I actually created a very simple version of this map with only a few points on it, and thinking I would need to give that to him first so he could learn how to use the software. But for Victor, he jumped right to the main map. He didn't even look at the smaller one. For another student, if I was starting this with maybe an elementary or a middle school student, I would pick their local neighborhood and do a few points in the neighborhood, do some intersections so they get the streets, maybe do around the school. I would choose how many points I put in there according to the student, their abilities, according to the location that I'm doing, and also whatever the goal is of what I'm trying to teach with this map. So just like I make a tactile map for a specific student, I'm always looking at what my goals are, and then I make a map around that. The nice thing about these maps is I can then take a really simple map and keep adding to it. Or I can take a more complex one and choose to make it more simple.
Right, and I wanted to add there to that as an experienced tech-savvy blind traveler who uses GPS, one of the challenges that I find with mobile GPS apps is that there's just too much information, and it's really hard for me to find the information that I need to achieve the objective that I'm trying to achieve. So I've come to, we've only been working with these maps for a few months because it's brand new technology, but one of the things I've come to really enjoy is the fact that there's less information that removes all that cognitive clutter so I can focus on the task at hand. All right. Well, any more questions, Lisa?
Oh, yes. We've got lots of really good questions. Somebody wants to know, how long did it take Diane to create the virtual map, adding the landmarks and such?
Okay, with this map of Elon, it took me maybe 30 minutes to make this map. I did another one for UNC, the University of North Carolina, which has a ton of landmarks. And that one probably took me close to around 2 hours to do. Part of that was I was trying to figure out what it was that I wanted to do. Now I have some best practices in mind. So if I were to recreate that map, it would not take me as long.
And I can, after looking at that map quite a bit of UNC, I can tell you that it currently has 178 points on it versus 47 here for Elon. So, that's oddly enough, that's a pretty linear scale, about 30 minutes versus 2 hours. Yeah.
I love this question from Jack because it speaks to practically using what we've got here. And Jack wants to know, does it always list the direction or distance to your previous location when you move to a new one?
It does not list the direction distance to the previous location when you move to a new one. That is not something it does, but I do wanted to just share that there are some options here for controlling the amount of verbosity of information that you get. So let's see.
Map view SAS graphics accelerator dash Google Chrome. Download as a.
Oops. There we go. Let me press C.
Verbose.
And let's try verbose.
Label equals Fonville Fountain. Acoustic landmark. Direction equals 110 yards at 3 o'clock.
Okay. And then let's press C again.
Off.
Now I've turned speech completely off. Now I'll just get the tone.
Label.
I can hear just the label.
Fonville Fountain. Acoustic landmark.
Now, I use this as an experienced user of this software. I end up using just hearing the label most of the time because I rely on the spatial audio and the pitch of the tone that I hear to guide me as far as the relative location. And if I need it, then I'll press C
Terse.
And I'll move to a terse mode, and then you'll hear what we were hearing earlier.
Fonville Fountain. Acoustic landmark. 110 yards at 3 o'clock.
Right. So if I were to jump to that location, I could always cycle back to my current location and understand the reverse relationship, like we did earlier with the two points of interest. Okie dokie.
Cool. And I know we're at about 3:30 here, but it's like we gave Catherine $1 to ask this next question. Catherine wants to know, what are your recommended best practices for creating useful maps?
Diane?
Okay, well, I am actually in the process of writing up best practice on what to include and what not to include as we're developing more maps and trying them out we're getting a really good idea. So stay tuned on that. I will write a post about that soon. I do want to mention that there are posts on Past Technology about these maps. So the Zoom lesson that Victor had, there's a post on that. There's a post on how to create these maps. There's a post on all kinds of different pieces of using these maps. So, and I see a lot of questions popping up that are answered in those posts. So I just want you to know that they're, we have references, and Ed's going to show you that in a few minutes on where to find those.
Yes, we do have a lot of questions about that. And you're right, and the information's out there. And Sandra wants to know, what would it sound like if the points being explored are north or south versus east and west?
Right. Let's see if we can explore that a little bit here. Let me go.
Smith Alumni Gym Sport 117 yards at 12 o'clock.
All right. So here's a point at 12 o'clock. Let's do north.
Alumni Gym Sport 117 yards at 12 o'clock.
Right. And it's it may be about what, halfway, a little less maybe than halfway out. And it's perfectly balanced between my ears. I can hear this with my spatial audio, and it has a pretty clean tone. Now, as I work my way around...
You are at Virginia Residence Hall. Young Commons on East Haggard Avenue, 100. Smith Residence Hall, 200.
All right. Now, that one has more of a tinny sound.
Smith Residence Hall, 223 yards at 3 o'clock.
All right. And that's probably just below the 90-degree mark. I can hear it's tinny. And that's what happens when the point is below the lateral line between 90 degrees and 270 degrees. It sounds a little tinny or a little different. It's subtle, and also in the spatial audio, that is reinforced by a little, I can't even explain it. It's a little bit of a difference in the spatial audio that you hear when you're using earbuds. Okay, hopefully that answered your question, but I would encourage you to get a pair of earbuds, download SAS Graphics Accelerator. I'll give you a link here, as Diane mentioned. We have a link for some resources that you can use to explore on your own, and I would encourage you to try it with a set of headphones or earbuds. The better your headphones or earbuds are, the better your experience will be.
Do you want to take some more questions, or do you want to keep going?
Yeah, let's take a few more.
Okay.
And we might defer some of them if they're answered, by resources we can provide. Yep.
Absolutely, yes. And I can tackle those too. I can help with those offline. Holly wants to know, is the program compatible with other screen readers?
Oh, absolutely, yeah. We test SAS Graphics Accelerator with JAWS, NVDA, and VoiceOver on Mac. There are some other screen readers out there, of course, that I would encourage you to try, but we can't test everything, but we do test those three main screen readers.
Here's an interesting question, Ed and Diane. Sherry wants to know, does this only work with a special cane? This might give you an opportunity to talk about what you're using to navigate the map.
Yeah, so we talked about the virtual cane, which you should be able to see on my screen. If you can see the screen, you would see extending from the point in the very center of the circle on the screen out to the edge is this thing we call the virtual cane. And we call it that because it functions a lot like a long cane in the real world, in the physical world. So the virtual cane is built into the software. It's just an artifact of the software, and it's just kind of modeled on the user experience, if you will, of canes that we use in the real world, long canes we use in the real world. So I think the short answer is, regardless of what kind of physical cane you have, I hope that you or your student will find that the virtual cane is a good metaphor to your physical cane.
Cool. Here's an interesting use case, Luis. I apologize if I'm mispronouncing your name, Luis. Can we take a printed or PDF map, scan or upload somewhere, and use this tool to explore? The use case being wants to use it for middle schools or high schools for transitional students or blind staff members going to a new campus.
Yeah, that's a great use case.
It is.
Currently not possible, though, to scan an existing image. But Diane, what would you recommend for that use case?
Okay, well, I make these maps using Google Maps. So if you were going to a new campus, I would pull up the campus, if you're going to a new location, I just pull up that location in Google Maps and make my map from there.
Right. And we have a couple posts on that we'll refer you to. And our last webinar in May was on this specific topic, creating accessible maps using Google Maps and SAS Graphics Accelerator. So in the resources that you'll see here in a minute, there's a link to that previous webinar.
So, and again, on Pass the Technology, we have the steps written out step by step. And then there's also the webinar and some videos as well on how to create your own map. So you have just about every way you can think of to help you create your own.
Mm-hmm.
Mm-hmm. Okay.
Okay.
And so a practical question, because you guys had talked a little bit about using tactile maps. Alice wants to know, what are you using to create your tactile maps?
Diane?
So what am I using to make my tactile maps? Okay, a lot of different things. So I will use homemade things. I use a lot of foam board to make tactile maps. I will use, recently we were doing some things with I can't talk. Ed, what's the name of that? Touch Mapper.
Touch Mapper.
Touch Mapper.
Touch Mapper, where you send your information to them and they will either make you a 3D map, or you can use that link and print off your own tactile map, or use a PF machine and print it that way, emboss it that way. There's lots of ways to make tactile maps. Sometimes I will use kits from APH to make a tactile map. It depends if I want it to be a one-time use or something that I use over and over again.
We've got a couple of questions about, Megan wants to know, does this program work if campus is an open area, not on city streets?
Oh, absolutely.
Mm-hmm.
And the way that Diane made this map, she listed intersections of roads. Mm-hmm. But if you have kind of a closed area that's more of a, what would you call that? Kind of a greenway feel.
Commons area. Mm-hmm.
Yeah, there you go. That has sidewalks. I would highly recommend that you provide names for the sidewalks and perhaps some indication of, main north-south sidewalk or something like that. That would help orient your student, right, or the consumer of the map. So you can certainly list sidewalks and intersections in that regard, because I believe they'll show up on Google Maps, and if they're not there, then you can always turn on the satellite view, and you can literally see the ground within Google Maps to do that. Mm-hmm. Diane, do you have anything you want to add there on sidewalks and that kind of thing?
Right. And practically, there were a couple of questions in there about, can you use this if with the open sidewalks and all of that. Mm-hmm. When I took Victor over to campus and he knew where the quad was, where the big common area is, he knew from his mental map where he was in, at the bottom of the quad, and the building, the gym was over at 11 o'clock. And he figured out going across all that open space on the sidewalks, and there were tons of intersecting sidewalks, and he kept in his mind that 11 o'clock and the distance, and went right over there, figured out which sidewalk to take, and zigzagged his way around till he got to where he needed to be, even though there wasn't a straight sidewalk to get directly to that point. So yes, it is very doable to use this big mental map and figure out your own shortcuts without having to go to the street and go around by the street section, sidewalks.
I love this question from Debbie. Can you also use open street maps? She says it has more accurate information for rural areas.
You can. That is true. You can, if you are technical enough to get the coordinates out of OpenStreetMap into a KML format, which is kind of a technical term, then you can absolutely import data into SAS Graphics Accelerator from OpenStreetMaps. You would have to use the keyhole markup language format, KML format. And if you're technical, then you can take, of course, GeoJSON and convert that to KML. So Yeah, that's a possibility. There's not a clean, a really clean kind of a no code route right now to do that, but that's certainly a possibility.
And Rhonda wants to know, how would you do this inside buildings? How would you create a map of the floor plan of the building if you have access to the floor plans? Interesting.
Yeah. That is a great question that we have not tackled yet. We've been having a lot of fun with metropolitan areas and campus areas right now. This technology is very new. It became production literally about, a month ago, 3 or 4 weeks ago. It was pre-production, experimental before then. And we're adding to it all the time, and we're trying to figure out how we, meaning people who are blind or visually impaired, can use it effectively, and orientation and mobility instructors can also teach it. And I'm blind, as are 2 of my colleagues on the accessibility team at SAS, and we together, the 3 of us, are the primary driving force behind the technology. And we are very much interested in indoor maps, but we have not tackled that area yet. So give it a try. These maps are completely 100% based on latitude, longitude. So if you can determine, let's say in Google Maps, the latitude and longitude of the corners of your building and construct the position of the points within the building, then I have a very strong suspicion that's going to work. But give it a try. Let us know.
Yeah, we'd love to know about that, wouldn't we? Glenn has a great question. I understand the spatial aspect, objects that are west in the left ear and east in the right ear. For objects that are directly north or south, is the sound equal in both ears? You just have to know 12 o'clock is straight ahead or north, and 6 o'clock is straight behind or south.
Yeah, that's a great question. There's a couple of questions in there. The first one, is that knowing your cardinal directions or clock face or bearing, right? There's 3 different options you can use within this software to communicate direction, and those are the 3: clock face, like I'm using now, cardinal directions, or a real mathematical bearing, like 323 degrees, for example. So that's the first thing. Having that foundational skill is absolutely essential. Then the spatial sound and the tone of the sound that's used it also communicates that information, and it's a little bit of a learned skill, to be able to understand that. You're right. It is more difficult to determine the points that are kind of in front of you versus behind you. And that's why for the points behind you, as I demonstrated, we added a little tinniness to the sound, which is subtle, but as you work with the software more and more, it gets easier and easier to determine front versus rear.
This is interesting. In terms of help, working with a student, how can you help anticipate entrances and details on different building levels with campuses that are not flat? I think they're talking about terrain and practical navigation of a campus.
That's a really good question, and we haven't explored that very much yet, given we're trying to develop best practices right now. Off the top of my head, I would strongly encourage you to list the entrance of a building on a map and maybe indicate that the entrance comes in on the 3rd floor, for example, versus the 1st floor. Let's say that the building is on a hill, or you might say something like upper entrance or versus lower entrance. And you have infinite freedom when you make these maps to provide labels for points in a way that makes sense for you and your student or whoever is going to use the maps. So that's my initial thoughts. Diane, do you have any other thoughts on that?
No, I think that's good.
Give it a try.
So
do you want to take some more? Or you want to press on?
Yeah, I just wanted to mention there are like 24 more questions that have popped up. So there's tons of questions.
And there's some I can answer. In terms of, how do I get the accelerator and things like that. So.
Okay.
3:44 p.m.
It's 3:44. Let's see. Maybe you guys have both read the Getting Started post that we're going to share momentarily. You want to scan for anything that isn't answered by
Yes,
that post?
I can do that. Absolutely. I love this question. Would it be possible to create a map of the globe?
Absolutely. Yes, we've done that. Sure.
Yeah. Mm-hmm.
And thank you for asking that question. This technology was originally created to satisfy both scientific, academic, and professional needs regarding the analysis of geospatial data. So as an example of that, we've created maps with every country in the world and the population. We've created maps with the capital of every country in the world, which I believe, if I'm not mistaken, I think it's about 200 something countries now, maybe 270. I'm doing that from the top of my head, which was an amazing thing. You know, I've lost my vision almost 20 years ago, 17 years ago now. And I just haven't been able to see a map for that long, or much less a globe. So, and I've literally forgotten how, like the Middle East and South America, over time, I've forgotten how those countries are arranged, you know, because I don't reference that information. So every time we get a new data set and we create a map, it's just, you know, it stops my productivity because I have to go explore the map and relearn those things. And it's just fascinating. So you can absolutely do that. The way you do that is to find the data in using latitude, longitude, WS84, if you know that, digital representation. So for example, let me just do this. You can hear this right here. This is what it sounds like. I have a command here that I can use to report my current location, and it gives latitude, longitude first. So here we go. Listen to this. Oops, that's the wrong one.
Your coordinates are 36.10232 degrees north, 79.50538 degrees west. You are at Virginia Residence Hall. The radius is 250 yards, showing 12 of 47 objects.
Okay, so we were at, what, 36 degrees north, 72 degrees west, I think it was. That's the kind of format that you need your coordinates to be in. And then if you have those two, latitude, longitude, as well as a label for each point, you're off to the races. You can create a map by importing that CSV file or Excel spreadsheet into SAS Graphics Accelerator. Now, if you go to support.sas.com/accessibility, that's the SAS Disability Support Center, and then kind of scroll down and look for the webinars section and click on that link for the webinars. We did a webinar back in about April, I believe it was April or March or April, where we walked through how to import data into SAS Graphics Accelerator and create a map that way. So I would encourage you to go back and find that webinar and get your data, and you should be off to the races. For you dual certified O&Ms and TVIs out there, there's wonderful potential here for your students to use this technology both for O&M purposes and for social studies, for history, for economics, anything public health related. There's just a whole host of disciplines that require the use of maps and at least an understanding of geospatial data. So give that a try and let us know. You can always send mail to accessibility@sas.com. That's accessibility@sas.com with any questions, or if you find something that works really well, we'd love to hear about that too, because we love the success stories.
We do. Diane, I see you've tagged a question that you wanted to answer live from Joseph about TMAP. Did you want to tackle that?
Well, I just added a post on how to create 3D printable maps using TouchMapper, and in that post on Passive Technology, there is also information about how to send it to your embosser and emboss it out yourself or to a PF machine. So that one's available. I know we're going to run out of time, so I saw several O&M specific questions. If you want to email me directly, or you can always reach me through Passive Technology as well, send me your questions and I'll be happy to answer them. I just know we're going to run out of time. So Ed, it's 3:49.
Okay.
I think some of the questions will be answered if you go and you show the post on where you can get all the information of how to get the accelerator.
Okay, let's do that. I'm going to press Control W.
Elon University detailed map dash Google.
And forgive me, I'm going to speed this back up a little bit.
Slower, faster.
Just so I can hear.
The map contains 47 points.
And let's close that.
W, SAS registered accessibility webinar : exploring accessible campus maps using SAS Graphics Accelerator Google Chrome. SAS.
Okay, please excuse my my screen reader here as we just show this really quickly. This is the landing page for the webinar on support.sas.com /accessibility. And this is where you probably registered. So I'm going to just jump down. I'll use the H key here in JAWS just to jump down.
SAS registered accessibility webinar : exploring accessible campus maps using SAS graphics accelerator heading level 1. About the webinar heading level 2. Target audience heading level 2. Registration heading level 2. Recording heading level 2.
Okay, there's a section here for recording. As soon as we get the recording up and captioned, we'll post the recording, and I would expect that to be next week, maybe next Wednesday or so. We'll shoot for that and get it through our video process here at SAS.
Related resources heading level 2.
And then there's a section here for related
Getting
resources.
started with non-visual digital maps link.
And the first link in this section is called, as you heard, Getting Started with Non-Visual Digital Maps. I'm going to open that link.
Control-Shift-Enter, Untitled Google Chrome. Getting started with non-visual digital maps, vertical bar paths to technology, vertical bar Perkins e-learning Google Chrome, over non-visual.
Okay, so this takes you to our blog post here on Perkins Paths to Technology. And I'll just skim through this really quickly and show you a few of the highlights. Now, we wrote this specifically for the folks that are attending this webinar to help you just dive into more information. We tried to anticipate what you might need given this is new technology. And let me just press H to jump down through here.
Learn how to create non-visual digital maps heading level 2.
Let me go back up.
Guide yourself heading level 2. Case study : Victor and Elin University heading level 2. Non-visual digital maps are explored using a
There we go.
case study : Victor and Elin.
Okay, hopefully you can see this section here for the case study. Diane has written several wonderful posts that include explanation of and videos of Victor as he both explored the map on his computer before he went to campus, and also the follow-up of the on-campus visit after he had built his mental model. So there's 2 posts here with videos. They're really thorough and great. I would strongly encourage those.
Try it yourself heading level 2.
In the Try It Yourself section,
Getting started with non-visual digital maps, vertical bar paths to technology, vertical bar Perkins e-learning Google Chrome. Visited link SAS graphics accelerator for Google Chrome.
there's about a 7-step process here for getting started. The first thing you need to do is install SAS Graphics Accelerator. It's free. You can install it from the Chrome Web Store. There's a link right here. And after you do that,
Non-visual digital map of Elin University link.
there's a link here to the map that I demonstrated during the webinar, so you can go explore that yourself. And then further down here in this list, there's some keyboard commands that you'll need to get started: page down, page up, and that kind of thing. There's a list here. And then finally,
Learn how to create non-visual digital maps heading level 2.
we had a bunch of questions about creating maps, which is great. We have a couple resources here for that.
How to create accessible digital maps using SAS graphics accelerator and Google Maps post link.
This is a link to a post also on Paths to Technology that gives you the step-by-step directions for creating Google Maps. And if you're familiar with Google Maps already, I would encourage you just to jump right in and see if you can get through it. There's detailed steps here. And then
Creating accessible maps using SAS graphics accelerator and Google Maps webinar link.
this is the webinar we did back in May, that walks through that process and dives in a little deeper. And during this webinar, Diane actually brings up Google Maps and shows you how she goes about creating a map herself.
List end.
So,
Additional non-visual map.
and then of course there's some additional resources here, and there's a wealth of information on Paths to Technology about a great many topics related to the technology and visual impairments or blindness. And many of them are also specifically focused on O&M. We are adding more posts on almost a daily basis as we continue to kind of build out best practices and other use cases of this technology. For example, I'm very much looking forward to adding some use cases for on the academic side, both science and humanities and economics and history that would support that kind of learning. So I would encourage you to check out Paths to Technology. Both you can click on, you can search for my name as a blogger or Diane's name as a blogger and see the lists of posts that we've posted. So I encourage you to do that moving forward so you can find more posts about this topic. Anything to add, Diane?
I think that's great, Ed.
Yeah, all right. Well, this has been a really terrific group. Thank you so much for all the wonderful questions. This is our final webinar in our spring series. We haven't quite planned out next fall, but it is our goal to get started again in September with an additional fall series. So I would encourage you to join us then. The recording of this webinar will be available next week. If I can figure out how to do it inside of Zoom, I'm going to send you all an email with that link. If that doesn't happen for some reason, please, if you check back on the landing page where you registered, you will find a link to the recording there. And if you have any questions for any one of us, please email us at accessibility@sas.com, accessibility@sas.com, and I will answer it for you or route it to either Diane or Lisa so they can answer it if needed. So thanks for joining us. Hope you have a great summer.
Thanks, everybody. Thanks, Ed. Thanks, Diane.
Thank you.